Hi everyone, good day. Are you ready for another Math Venture with Teacher Rev? Let's start our statistics learning journey.
If the mean is greater than the median, it's skewed to the right or positively skewed. If the mean is less than the median, it's skewed to the left or negatively skewed. But teacher, is it possible for us to solve for the skewness? Is there such a thing as coefficient of skewness? There is such a thing as degree. Okay, we can actually find this measure of skewness by computing through the formula below, which was introduced by Garrett in 1973. Sk is the coefficient of skewness, which we will be able to relate later to the values that we have here. How do we look for that? It's 3 times the mean minus the median divided by the standard deviation. Let's summarize the table that we have. Okay, that's not mean, but that's normal. Can you please change that to normal? That's normal. This is skewed to the left and skewed to the right. We have the mean, median, mode, and the standard deviation. I already computed for the standard deviation. Later, we'll apply this to one problem and we'll look for everything. First, we have 3 situations here. One that is normal, one that's skewed to the left, and one that's skewed to the right. Skewed to the left is also known as, later we'll know. Okay, skewed to the left is also known as negatively skewed, if you can still recall. And skewed to the right is also known as positively skewed. Okay, we know that already based on the definition we identified earlier. This time, how do we solve for the skewness? Remember, skewness, I'll write it here, is equal to 3 times the mean minus the median divided by the standard deviation. Okay, in symbol, we have 3 times the mean minus the median divided by the standard deviation if we are talking about population, or we can actually change it to sample. Okay, that would be nice. So in this case, it's given already. So we have to get the skewness of a normal distribution in the given data, we focus on the first column. So 3 times the mean, which is 4, minus the median, which is 4. Remember, in a normal distribution, the mean, median, and mode are equal, divided by the standard deviation, which is 1.53. Obviously, 4 minus 4 is 0. Multiplied with 3, that would be 0. Dividing it with 1.53, the answer is still 0. So the skewness in a normal distribution is 0. Do you have any question with that? Do you think it will always be 0? Of course, it will always be 0. Why is that so? Because the mean is equal to the median. If we're going to subtract two values of two items with the same value, the answer will always be 0. So, if you solve for the skewness and the answer that you arrive with is 0, definitely the distribution is a normal distribution. Now, skewed to the left, how do we solve for the measure of skewness? Again, we apply the formula. Skewness is equal to 3 times the mean, which is 5.58, minus the median, which is 6, divided by the standard deviation, which is 1.07. If we're going to, let's use our calculator in this case. That is, let's just key in everything. 3 times the parenthesis 5.58 minus 6, close parenthesis, divided by 1.07, which is the standard deviation. The answer is negative 126 over 107, or approximately negative 1.18. Yan, okay, that's the skewness. Remember, what value did we get? A negative value. Okay. Remember, this is also known as negatively skewed distribution because the measure of skewness that you're going to arrive with is negative. So does it mean, teacher, if the value of Sk is equal to 0, that means the distribution is normal? Yes. If the value of the skewness that you arrive with is negative, is less than 0, does it mean that the distribution is negatively skewed or skewed to the left? Yes, also. Now, let's go to the last part. That would be Sk. Okay. Skewness is equal to 3 times 2.4 minus 2 divided by the standard deviation of 1.07. Okay. This is the same, but let's change the one inside the parenthesis. That would be 3 2.4 minus 2 divided by 1.07, the answer is 120 over 107, which is approximately 1 point. So let's summarize what we learned today. We know that a distribution can be skewed to the left or negatively skewed if the direction of the tail is in the negative direction and where the mean is less than the median. The bulk of distribution is on the right and the tail of the distribution is on the left. We also know that a distribution can be skewed to the right or positively skewed if the direction of the tail is towards the positive direction where the mean is greater than the median and the bulk of the distribution is on the left while the tail is on the right. Okay, and last, we also know that the distribution can be a normal distribution where it represents a perfectly symmetrical distribution. All of this we talk because we discuss about the skewness of a distribution, which focus on the measures of symmetrical or the degree of symmetrical or asymmetrical of a distribution. Another thing that we need to reiterate is that if the skewness is equal to 0, then the distribution is a normal distribution. If the skewness is less than 0, then it is a negatively skewed distribution and it's skewed to the left. And if the skewness is a positive value, which is greater than 0, then the skewness is positively skewed or skewed to the right. So that's it about skewness. This time, let's go to another focus. But before that, let's have an example first. Okay, find this coefficient of skewness and then indicate if the distribution is normal, skewed to the left, and skewed to the right. First thing is to identify the median. Remember, the formula for skewness is equal to 3 times the mean minus the median over the standard deviation. First, let's find the mean. To find the mean, we add everything and then we divide it with 10 because there are 10 items here. So we have 72 plus 81 plus 67 plus 83 plus 61 plus 75 plus 78 plus 82 plus 71 and last plus 67. That would be 737 divided by 10. That would give us a mean of 73.7. Okay, now for the median. For the median, since we need a median in the formula, we need to arrange the given values in ascending order. Okay, let's start with 61, followed by 2 67s, then 71, 72, 75, 78, 81, 82, and 83. That would mean the two middle values would be 72 plus 75, 72 and 75. So we need to get the average of that divided by 2. That is, okay, let's just add 72 plus 75. I'll get the total first, then divide it with 2. That would give me 73.5. So it's 73.5. I have a median of 73.5. I have a mean of 73.7. This time, I need to get the standard deviation. For the standard deviation, I need to write all the scores here. So I have 61, 67, 71, 72, 75. Okay, I'll write 72 here. This is 75. Let me fix that. 72, 75, 78, 81, 82, and 83. Okay. It's supposed to be, if it's 73.7, that is score minus the mean. So, the score is 61 minus the mean, which is 73.7. I'll do it per row. Negative 12.7 squared. That would give me 161.29. Okay, this will take a longer time. 67 minus 73.7. The answer is negative 6.7 squared will give me 44.89. So since these are the same, I'll just copy negative 6.7 and 44.89. Okay, now 71. 71 minus 73.7, that would be negative 2.7 squared is 7.29. Okay, next 72 minus 73.7, negative 1.7. Squaring that would give me 2.89. Okay. 75 minus 73.7, 1.3 squared, 1.69. Okay. 78 minus 73.7, that would be 4.3 squared, that is 18.49. Okay. 81 minus 73.7, the answer is 7.3 minus, 7.3 squared is 53.29. Okay, I'm almost there. 82 minus 73.7, that would be 8.3 squared, 68.89. And last, 83 minus 73.7, that would be 9.3. Squaring that would give me 86.49. Okay. Then I need to add everything because for me to get the standard deviation, it's the square root of the summation of the square of the score minus over n. Okay. So that would be, I already have 86.49, so I'll add going up 68.89 plus 53.29 plus 18.49 plus 1.69 plus 2.89. Then we add 7.29. Then 44.89 plus another 44 point, and last 161.29. Okay, and the answer is 490. So the summation of the square of the difference of the score and the mean is 490.1. Okay. Let me fix that. Okay, that would be 490.1. Okay. So I'm almost there. So 3 times the mean. This is 490.1 over n, which is 10. Then I need to get the square root. So square root of 490.1. Then the denominator would be 10. That would give me an answer of 7.00. Okay, 7.00. 7.30. Okay, 7.007. Therefore, 3 times the mean, which is 73.7, minus the median, which is 73.5, divided by the standard deviation, which is 7. So, if I'm going to key in that one in my calculator, that would be 3 times 73.7 minus 73.5 divided by 7. That would give me approximately 0.08, 0.09 or 0.08. So if that's the case, if that would be the case, the value of the skewness is positive. So SK is greater than 0. Therefore, if it's greater than 0, is it skewed to the left, skewed to the right, or normal? We say that it's skewed to the left if it's negative, skewed to the right if it's positive, skewed to normal distribution if it's 0. Therefore, it's positive. Then, it is skewed to the right or positively skewed. Therefore, this is skewed to the right or positively skewed, and the coefficient of skewness is 0.08. If that is the case, then that would satisfy the condition that the mean is greater than the median. Remember, the mean is greater than the median. So it's positively skewed or skewed to the right. Okay, that satisfies our condition on this part. Do you have any question? Okay, that's good. It's a long process, but if you know how you're going to go through finding the mean, the median, and the standard deviation, the coefficient of skewness will be easier for us. And identifying the mean and median would already give us an idea of the kind of distribution we have in terms of the degree of skewness. So that's it about skewness. We'll continue with kurtosis. When we talk about kurtosis, this refers to the pickedness or flatness of a distribution. Normally, if the distribution is normal, which is the orange curve line here, it means that this distribution is known as mesokurtic. If the distribution is more peaked than the normal distribution, just like the blue graph here, then we call that distribution as And lastly, if distribution is flatter or if the curve is flatter than the normal distribution, then we call that as platykurtic, okay, as shown in the given illustration. How do we possibly know, given the values in the data, whether we will have normal distribution, which is a mesokurtic, or a leptokurtic, or a platykurtic? There you go. We can actually do it using this formula for kurtosis. So we have for ungrouped data, we have KU, okay, but this is standard deviation for the population, so we use that symbol. For ungrouped data, we have this formula. So basically, it is somehow similar, but we need to identify, or we get to the fourth of the difference of the score and the mean. We also get to the fourth of the standard deviation. So we need the mean, the standard deviation, and the frequency. So let's start. For instance, we have this distribution. So to know whether the distribution is normal or mesokurtic, the KU, which is the one that we're going to solve for, the kurtosis, the measure of kurtosis should be equal to 3 so that we can identify it as mesokurtic. It can also be rounded to 3 so that we can identify it as mesokurtic. If it is greater than 3, we call it leptokurtic. If the KU that we're going to solve for, the kurtosis, the coefficient of kurtosis or measure of kurtosis will be greater than 3, then it's a leptokurtic distribution. And if it's a platykurtic distribution if KU is less than 3. Let's look at the data. So we need the mean. Again, to get the mean, we add everything. We divide it with how many values are here? 9. Okay, so we divide everything with 9. First, let's get the sum. 2 plus 3 plus 3 plus 4 plus 4 plus 4 plus 2 5s plus 6, that would be plus 16. Okay, so that's 36 over 9. And 36 over 9 is what? That is 4. Okay, so we have the mean. The mean is 4. This will be easier. So we subtract the score minus the mean. That's 2 minus 4 is negative 2. We square that. That would be 4. And getting the fourth would be squaring this. So squaring a 4, that would be 16. Okay, we have our values already. 3 minus 4 is negative 1. Squared is 1, and squaring that one would be 1 as well. Since it's the same, I just copy the third column. On the fourth column, 4th, 5th, and 6th, that's 4 minus 4 is 0. So I have 0 here, therefore I have 0 for all. Okay, that's good. Now, for the next one, 5 minus 4 is positive 1. Squaring that would be 1, and squaring this would be 1. Is squaring this the same as getting to the fourth value of this? Of course. Okay, so the next one is 1, 1, and 1 as well, because they are the same 5. Now for 6, let's try that. That would be 6 minus 4, that is 2. Squaring 2 would be 4. 2 to the fourth is 2 times 2 times 2 times 2, and that is the same. It's 16. That would be the same as squaring. Okay, now we have already to the fourth value. We need also the standard deviation. Okay, remember, the formula for kurtosis is equal to, let's recall, since this is ungrouped data, and let's use the population. We get this. Okay, summation of the fourth of the difference of the score minus the mean divided by n times the standard deviation to the fourth. Okay, so we have that. So we need to get the standard deviation. To get the standard deviation of the population, since we use population here, that would be the summation, square root of the summation of the score minus the mean squared divided by n. Okay, we know that n is 9. Square root of, what's the sum of this one? The square. 4 plus 1 plus 1, that would be 6. Okay, square root of 12 over 9. That will give us approximately 1.15, which is equal to, the numerator is the sum of this. What's the sum of this? 16 plus 16, 30 plus 4, 36. So the total of this is 36. So that would be 36 over n is 9 times standard deviation is 1.15 to the fourth. Let's just put it here. Key in these values in our calculator. 36, the denominator would be 9 times 1.15 to to the fourth. And the answer is approximately 2.28. 2.28. Let's round off 2.28. What's the rounded value of 2.20? That's 2. Okay, so that means Ku is equal to 2. If Ku is 2, that means Ku is less than 3, which shows that the distribution will have a peak of will have a platykurtic distribution. That means that the curve is a little flatter than the normal distribution. Okay, so that's it about kurtosis. Hope you understand everything now. So if you get a kurtosis of 3, that would mean that the graph is a normal distribution and it's mesokurtic. If the kurtosis that you acquired is greater than 3, that means it's a little peaked than the normal distribution. So it's a leptokurtic distribution, and it's platykurtic distribution if the Ku that you're going to get is less than 3. Which states that the graph would be a little flatter than the normal distribution. So that's it about kurtosis.
This had been a great learning adventure. So, see you next time on another Math Venture with Teacher Rev. Remember, don't stop until you're proud. Learning math takes time. Bye!